Today, we're discussing the AI impact on mathematics, a topic particularly important and dear to my heart. Our guest is Professor Ivan Nourdin, who is Professor of Mathematics at the University of Luxembourg and the head of their bachelor program in mathematics. He's also a co-founder of a startup, Grew AI, which helps private and public organizations in their use of artificial intelligence. He's a book author and respected researcher in mathematics. A few months ago, Sebastian Bubeck, who is a leading figure in the realm of AI and who is working for OpenAI these days, published on X a result from his interaction with ChatGPT Pro 5, which eventually, arguably, did a new mathematical proof. This led many people writing, hyping again how it's going to change the world, replace mathematicians, do scientific discoveries. And it was very important for me to find someone who was able to discuss this with his expertise and shed some light and common sense and expertise on these findings. And beyond being an expert in mathematics and in AI, Professor Ivan Nourdin also wrote a paper basically with the starting point of Sebastian Bubeck's claim and try first to replicate the results also on his own and discuss it with other people, but then try to use ChatGPT to do some research in math and eventually find new mathematical proofs. In this fascinating episode, we discuss the post by Sebastian Bubeck, the research by Ivan Nourdin, the extent of these findings, its importance, the issues, how mathematics is evolving, how to use generative AI in mathematics, and the potential or not for automating math. This is the AI Impact podcast.
We both saw this story basically online on social media about Sebastian Bubeck posts basically claiming that with ChatGPT Pro he managed to make a new mathematical proof, if I understood well, within the realm of convex optimization, which is not something I master, but if I understood correctly. And then, of course, this kind of claim leads to a lot of hype of people writing and potential implications for mathematicians, but in the world in general, even for investments. So the interesting thing is that you also picked on this news and you decided to go further and do some research. But first, can you tell us more about what happened, what's behind this story, and your perspective on this?
Yeah, so this post by Sebastian Bubeck was posted also in August this year. And so the claim that was that GPT-5 Pro had been able to improve a bond in convex optimization in just a few minutes. And that was the message. And Bubeck takes this as a proof that AI can now do real research level mathematics. And okay, it was not really the first time that capability of doing advanced math was reported, because, for instance, we had already seen AIs win medals at math Olympiads. We have alpha proof, alpha geometry, DeepMind, Google, etc. But this time, the message was a bit stronger as far as I received it, because it suggested that we reach more or less a turning point where this time LLMs, so large language models like ChatGPT or others, might start competing with professional mathematicians. And since mathematics is often seen as a measure of intelligence, but this speaks to many people. And I think that for OpenAI, of course, it's important to communicate around this, because somehow, as you said, it justifies the massive investments made in Gen AIs. And also, I think we must remember that we are still inside an AI bubble. So for the moment, it's not, yeah. And so Bubeck works at OpenAI, but before that, and this is why I know him, not personally, but I know his name. He was a researcher at Microsoft, and even before that, he was an assistant professor at Princeton. And interestingly, he studied at the École Normale Supérieure, like me, and he holds also a PhD from Lille University. So we are the same kind of studies, I would say. So this is to say that he is a real mathematician. So he's not just someone working at OpenAI and claiming something about math, but he's a real mathematician. And the point is that also I know his work quite well, because, for instance, a few years ago, I published a paper building on one of his ideas in random matrix theory. So this name, so for me, his name resonates to my mind. And so when I saw the post, I took it very seriously. But I cannot just read it and say, okay, it's great. No, we can use ChatGPT to do math. I wanted to reproduce somehow this experiment. So I opened my my ChatGPT and exactly write the same prompt, and it failed. Okay, but then there is, you can think of many reasons why this failed. So first, because he used GPT-5 Pro. So this is a version which costs like $200 a month, and I only have GPT-5 Plus, which is not just $23 a month, which is enough for what I do. But then I know also people having Pro, GPT-5 Pro, and who also failed to reproduce the experiment. So then you don't know if it was luck or something like this. And also there is something which makes these experiments quite difficult to reproduce. This is the way the LLMs are built. So there is this notion of temperature, which means that you can put exactly the same prompt and get something different if you're trying many times. So maybe it was an explanation. So maybe it tried many times and then it just make a screenshot of when it worked. And okay, another reason for which I was not quite happy with this prompt is that I'm not myself specialist of convex optimization. So even if I get something different, I did not want to spend too much time trying to check, etc. And the last thing is that I think today it's impossible to reproduce what he did, also because of the buzz, the hype done by it. No GPT-5 would be able to find a website where the proof is written and so on. Okay. And then we move forward, but then I would say also that we have two types of reactions, I would say. So on one side, we have a sort of buzz by non-mathematicians, because they can just comment. They have no idea of what is going on. They don't have no idea of what is research in mathematics, and they cannot really judge by themselves if it is just buzz or more deeper. So we have seen claims like historic day or AI discovers new math and so on and so forth. And on the other side, we have more nuanced views, like, for instance, Ernst Ryu, who is a professor in California, who reacted quickly and wrote something like, okay, the proof is new in a sense, but not very hard for an expert. Myself, I could redo it in a few hours. This is what he wrote, basically. So it was not clear really if we had something very new or something like an Olympiad exercise, not written, but somehow not so difficult to do. And the last thing about this is that we have also a very famous mathematician, maybe the most famous today, who is Terence Tao. And he also documents a lot how he uses now GPT-5 Pro to write code, to test ideas, and so on. So I think we are at the beginning of something. And yes, and so Bubeck post also helps people to understand that we are at the forefront of something quite new.
Mm-hmm. So just to react of some key elements that I want to be sure that I understood. You said other people also tried to replicate his findings using ChatGPT Pro and failed?
I know at least one person who contacted me by LinkedIn and told me that I have GPT-5 Pro. He's not a mathematician, but he tried to do it apparently, and he failed.
Okay, yeah, because the prompt and the initial file that was included in the prompt were shared. So indeed, you can, if this is the entire discussion, which probably we are not entirely sure, you can replicate basically what was done. The second thing I wanted, you partially answered this, but just also if you can go slightly deeper. So far as we know, this proof didn't exist anywhere.
Mm-hmm.
And the second thing is, how important is this? Can you give us some kind of feeling of how important is this kind of finding? So based also on the other discussion you had or finding by this professor, It's basically if someone wanted to find this solution sitting down at their desk, someone who is an expert in convex optimization, they will eventually get through this new boundary
Yeah.
over a few hours. Yes?
Yeah, this is what I call incremental research. So meaning that this is not written somewhere, but if you, as you say, if you spend a few hours, you know the tools to use, you have an idea of which tool you have to use, you know exactly where you have to go. So if you are a specialist, it's not the kind of problem which should be very difficult for you. It's typically the kind of problems that you can give to a first-year PhD student just to make him or her acquainted of the literature and to try to test and so on.
Okay. And how much guidance did he give? And do you need to do these findings, do you think? Do you basically we know that with LLMs, you need to filter in, filter out most of the time if you want something useful. And what I mean by this is, do you think that a non-mathematician will be able to ask the right question or not?
I would say so. The prompt by Bubeck, I think, was the real prompt he used. I am also quite sure that the answer was exactly this. So there is nothing which has been hidden to us. I mean, he was somehow maybe not lucky, but this problem of reproducing is because of the temperature, basically. So I mean, I can think because my experiment was more or less the same, and I get so a minimal prompt, and then I got something which was meaningful. The point is that in order to understand if or not, if it is meaningful or not, you have to be a mathematician and to know what, to know to be able to understand the output and to see whether it's correct or not and so on. So if you are already a specialist, but it's like for LLM in general. So if you are a specialist of the question, it can be very helpful. If you have no idea of what it is, so then you don't have the tools to see whether it hallucinates or not, and that's yeah, that's the point, I think.
Yeah, so that's the very important thing with Gen AI and the hype is that because some people loves to say, okay, rest in peace, legal work, rest in peace, I guess, mathematician now some will write. But the thing is, it's absolutely not true. It's the same with predictive inference, like machine learning, deep learning to predict a tumor or something with MRI and replacing eventually a radiologist. No, not at all, because you still need the expert, right, to filter out and to flag what's correct, what's not correct. And eventually here also, I guess, for math to ask the right questions. So if anything, it might help experts, people who are really high level in math to go faster because now they can just judge eventually under some conditions. And we can discuss this further, of course, but at least experts are still required.
Yeah, but the worry is that how to become an expert. I mean, if we know how there's tools who are able to short circuit a bit the training of an expert, then in the end we won't have experts again. And I think this is a problem of juniors because even in companies, no, we have this problem of companies not hiring enough juniors because they say that they can be replaced by AI and so on, which is partly true. But I mean, when you have juniors, it's also the forthcoming seniors, and I think for mathematics, it is exactly what can happen. So. But this is maybe something we'll speak later about PhD students and so on. But for instance, if you cannot give such problems to PhD students, because what they will do, they will just ask ChatGPT, you will not know, maybe. And then in the end, they learn nothing. They produce something which is correct, but they skip the learning process. And so, yeah, it's a problem, I think, in the end.
Yeah, 100%. And we have seen these recent papers with flows, but showing that eventually there is a decrease of the growth of junior position in work in general, in particular in the US. But again, there are some caveats, this research, but eventually, with what we know, there's a role of Gen AI in this. And as you perfectly stated, I mean, seniors were juniors, and how do you create I also teach a lot and have like 1,000 students per year, and this worries me a lot because to learn, you really need to wrestle, to spend some time. I mean, if I remember some very simple things like I haven't done for years, but just matrix multiplication or things like this, it's just because I did it many times by hand.
Yeah, and you have to fail. You have to
Yeah.
see that you don't know how to do, and so ask you questions. How can I do this, and so on. For me, it's like if you watch Roland Garros in your TV, you don't know how to play tennis. So,
Yeah.
I mean, if you can read and understand what is correct, but you lose an ability to be able to produce your math yourself, and in the end, yeah, it can be very problematic.
Yes. And moreover, before going to your paper, I still have also, with this story of Sebastian Bubeck, there's also this conflict of interest. If Sebastian is working for OpenAI and OpenAI is losing money, so they started also to attract, and in with Gen AI, it's generally the story, right? They still struggle to have some positive return on investment with their tools, and basically they still attract billions of dollars.
Yeah.
And the narrative to attract these billions of dollars have been from the beginning like, we are going to cure cancer, we are going to build AGI, for example, if you listen to Sam Altman. And basically, this justifies everything. We are going to solve eventually climate change and cancer and children dying. So, is there anything not worth basically putting to solve all these crises? So give us your millions and let us build large centers, computational power and centers, even if it's costly for the environment. And this enters also in this narrative, basically this story. That's where it might be also problematic, is that then people might claim, well, it's going to solve big math problems. As you said, you have this, always we perceive math as a good test for intelligence.
Yeah.
Exactly. Yeah. So I think there is also this tension that is sometimes risky when we go in this direction with these claims
Yeah. But also Gen AI is also not reliable at 100%. And for this is maybe something we will also discuss later. But for a mathematical proof, I mean, even if you have a small error, like a plus being a minus, so which would count as a 99% true, but the proof collapses. So I mean, for mathematics, Gen AI alone is not enough. So it can be part of the process to produce math, but then even if you rely on human beings checking or verification, we can also do some errors and so on. And yeah, so we will have to plug this with other tools like Lean and so on. But maybe we discuss this a bit later. I don't know.
But no, I had this exactly in mind. So for me, when I discuss about the potential for AGI and things being better than top researchers, top experts in the world, usually the starting point is taking AlphaGo. Because basically, you have AlphaGo, you have this very demanding Go board game. And a few years ago already, the best in the world, Lee Sedol, was beaten by AlphaGo. And eventually here, the narrative is, if you look at the underlying paper, by the way, which you probably know, they train first with supervised learning. So basically, they try to replicate what humans are doing. And then basically the final model was trained using reinforcement learning. So basically you just Go is a verifiable domain. Is basically the tool can judge if it wins or not and verify the answer. And hence you can just play millions of times and improve yourself by seeing what works, what doesn't work. And leading to this, I'm very curious about your perspective on this because typically math from someone who is not advanced as you can think that it's a verifiable domain, like a machine could verify with certainty if it's correct or not.
Mhm.
Is it the case when you do advanced math or not necessarily?
Not necessarily, because so I mean, there is a process when you create some mathematics. So first let's say you have so first you must find your problem on which to work. Then you have a rough idea on how it should work, and then you divide into steps, and then eventually you manage to prove each step and so on. And then you have to check what you did to be sure, because we have some proofs like which are like 100 pages of mathematics. And you know, again, that if there is something wrong, even a small step or something which could think it's just a small step, then in the end, the proof might be completely wrong. And the point is that we know that LLM hallucinates, so we have to check for sure. But how do we check? So this is a proof assistant. I mean, this is something which has been started many years ago. But like AI is a technology that existed 70 years ago. So it started with Turing and things like that. But then now it took more or less 70 years to have a technology which can be useful by the whole planet. And for mathematics, we are in the era where we have the technology. We know how to formalize things in order to have something which can be checked automatically. But now we need data. Because with Lean comes MathLib, which is a library associated to Lean. And the point is that the development of mathematics nowadays, and even more with this amplification due to Gen AI that we might expect in the future, there is a big gap between the massive production of mathematics, for which we are not sure that they are all true, and the few people who are working for MathLib, for trying to expand MathLib, which would be what we need in order to check that everything is correct. So here we have the technology, but we are like in the area where we have the technology, but no data to train the models. So here it's a bit the same. And so for the moment, we cannot expect an immediate future, a short future, where we would be able to produce mathematics and to have a system that check everything, and in the end we just did nothing, and it works. Yeah, because of the lack of data, I would say.
Okay, yeah, so no scaling yet, like you feed these are all the problems that will give you a Fields Medal, a Nobel laureate, and you try to solve, and you just let the models go for it.
Okay. So we are very far away from this.
Okay.
And even with LLMs, we are not sure that how creative they are, because you can just try them on some problems you have in mind. We all have mathematicians, our open problems on which we like to, so we can test on them and so on. Sometimes it works a bit, sometimes not at all. But for the moment, it's just by luck, I would say. You have no idea before starting to make this system work on the problem if it will go somewhere or not.
Mm-hmm.
But exactly like when you do research, you have no idea when you start if you will be able to solve the problem or not.
Yeah, 100%. One last thing before going to your paper, about the math Olympiads and the capacity of LLMs to solve some of these problems, or many of these problems. I'm not sure about the benchmark these days. And is it something that typically the answer exists somewhere and it's just a reflection of the capacity? Basically, it's kind of the LLMs doing the exam open book with the capacity to look for the answer, or are these tools really able to pick different pieces of math, basic fundamental tools, and really solve problems? What's your feeling about this?
Well, first, I'm not a very specialist, so what I'm going to say is not 100% sure, but for me, there are exercises. So, I mean, at least someone knows about the answer. They are prepared by like Fields medalists and so on. Some of them are very involved in this. So they are exercise, but one of the top of exercise you can think of. But normally people who are doing this exercise, who are producing this exercise, know they know how to do it. And another thing is that so I never participated myself, but I know that there are many universities or schools that try to prepare students to this thing, like in sport, I would say. So for sure there are some tricks, some techniques, some things that are quite always the same, and for a machine, if you have all these tricks, and so if you have a database which is big enough, it's less difficult, I would say, to solve this, even if it is really impressive that they can win like gold medals and so on. But it's less impressive than producing research, which comes basically you have no idea which tool you have to use. Even to state the result you have in mind, it can take also a lot of times and so on. So it's, yeah, you are more in a given, you are more framed, I would say, with Olympiads than for research, which can go by principle everywhere and take any form. And, yeah.
Okay, I see. Very, very interesting and useful to know. So now also we can move to your paper, basically going beyond this anecdotal post and the first part of this discussion. You actually did some research, starting with the claim from Sebastian Bubeck. And can you tell us more about this paper?
Yeah, for sure. So first, I wanted, as I told you at the beginning, to form my own opinion because okay, we have this claim and so on. And at the time where Bubeck posted, so it was end of August, I was in Japan for a conference, and I wrote to my postdoc and my PhD students, so have you seen this post? And I think it's interesting, and I suggested them to try a similar experiment. But this time, not just a post and say, wow, we are the best and so on, but in a serious and fully documented way. I wanted really to write a paper where we explain exactly what we did and what was okay, positive, what was more negative and so on. And I wanted also to do it in a field that I know perfectly because like convex optimization, I'm not a specialist. I can read the mathematics, but it takes me time. So and it turns out that 20 years ago, I'm most famous for, in my area, for the Mayer-Einstein method, which is something I introduced with a colleague of mine, Giovanni Peccati, so 20 years ago. And so I'm the creator of this theory, so I know it by heart, and I followed all developments of the last 20 years. So we have we have something with a lot of results, a lot of branches, and so on. But I was at the very beginning because I created it. So I think that, yeah, it could be a very good idea to try to reproduce such an experiment, but in this framework. And the point is that also 20 years ago, when I invented this, I felt that it was something which will have a lot of ramifications and interest because, well, sometimes you discover something and you know that you discover something deep, and so I decided at that time to maintain a web page which would be accessible to everyone and which gathers all publications that have to do with my method. And so I have a database of 300 even more papers using this theory. And so I told my PhD student and my postdoc, okay, let's pick one of these most recent paper and try to find a theorem inside this paper and ask ChatGPT to extend to something. And so we picked one of this paper by Bas O'Connor, Kramerbank, and Svensson. And okay, I won't explain exactly what we did because it's a bit too advanced, but basically the paper proved that a certain random sequence converges to a Gaussian distribution, the normal law. So it means that just you have a random quantity and it becomes closer and closer to the Gaussian distribution.
Is it the central limit theorem or something?
It's related, yeah, it's related to central limit theorem. But you know, in the central limit theorem, you have no idea at which rate this convergence takes place. And that's exactly what my method, Mayer-Einstein approach, can measure. So we asked ChatGPT-5 to turn this qualitative result, convergence to the Gaussian, into a quantitative one. In other words, not just, okay, it converges, but how fast does it converge? Okay, so we have the perfect candidate. And so we use the minimal prompt. So let me read it. It was a turn theorem X, let's say, which is qualitative in nature, into a quantitative result using the Mayer-Einstein approach. And we gave it two files. So one, the file by Bas O'Connor et al., the paper I wanted it to transform to a quantitative, and another one, lecture notes that I wrote about the Mayer-Einstein approach. So he had the problem, he had the tools. And so it was first very impressive because GPT-5 understood the problem structure. So with just this minimal prompt, it started to answer. And So he explains that, okay, the result you can prove is this one. And in order to prove it, you have step 1, step 2, step 3, step 4, step 5, and so on. So if you are interested, or you can really read the paper, we explain this. Okay, but then we had the steps, and then I thought ChatGPT that, okay, I'm not, he is not my supervisor, so so please give me the details of all the steps. So I started to say, okay, no. So it's like you have the sketch of the proof, step 1, step 2, step 3, and so on. And now you have to be sure that each step is correct. So there were another reflection, like a few minutes, and then it was writing, okay, no, we have the whole proof. Here is a proof for step 1, step 2, and so on. And so we started to check what was written. Again, it was very impressive because so if I had a PhD student writing this to me, so I would have been very impressed, because it means the good tools, the good way of thinking, and so on. But then it turned out that there were a subtle mistake somewhere, like a plus being a minus, so more subtle than this, but this is kind of error. And of course, as a specialist, I saw this immediately. And so I did not want to say, okay, this is wrong because blah, blah, blah. I just say, okay, can you give me the proof of this identity you wrote? Or can you check it again, or something like this? And it answered, yes, it's true, and here is a proof. And so he gave me another wrong proof. Then I say, okay, no, it's wrong here what you wrote because this and this. And then, of course, because each time you ask something to an LLM, he always agrees with you. So he says, okay, you're right. And now finally he gave me a correct proof for this step. Okay, so it was able to produce something new, coherent, and then we did something else. I asked it also to turn this into a research paper, so writing the LaTeX file and so on, which it did perfectly. Then I asked about some extension I could do, and so it told me maybe you could extend this to the Poisson case, which makes sense. So I opened a new discussion, and I asked it to extend also to the Poisson case. And in this case, it did something correct, but not the best result. So basically putting some of the conclusion in the assumption, like if you are lazy, so you want to put something, the conclusion, you put some part of the conclusion in the assumption, so that you have nothing to do, basically. Okay, but it was interesting. And the point is that, okay, so it's not completely correct because of this mistake. We need to be a specialist to see that there were a mistake. But also, I must also say that this is a state of things now in 2025. And I remember when ChatGPT was released in 2022, he was speaking about co-eggs and things like this. So 3 years later, he's able to do something in a mathematical theory I invented. So yeah, what will be in 3 years? I don't know. So it's quite impressive.
And typically this kind. So thanks for this overview. Sorry, I just taking note of my questions. And basically, the question you ask, would you say again that this is something, if you give this to one of your PhD candidates, they would sit a day, a week, and they could solve it eventually?
Depending on what they know already on Mayer-Weinstein approach. Because the mistake, I think we are 10 on the planet to be able to see the mistake. So I mean, this is a mathematical mistake. So normally every mathematician should be able to fix it. But this is a kind of mistake you just see only if you are a specialist. So it was not so difficult for me to guess that it will make an error exactly here. Okay, but then to answer your question, so if I give this to a student, a PhD student, I think I would have been exactly the same mistake. And it would have taken maybe 1 week to a student first to read the Mayer-Weinstein approach, to try to understand what it is and so on, then to read the first paper, to understand what was done and what is new and so on. and when I say 1 week, it could also be 2 weeks, because you need to digest all this and so on, and to make this problem your own problem, which takes time because you need to mature it. And yeah, it's impressive because you get this after 5 minutes of thinking. But with this error, which again, it's an error that I think a PhD student would have been also would have done also, yeah, exactly, because it's something quite subtle, and once you have seen it, you remember it and you will never do it again. But if it is your first time, maybe you do it also. Yeah.
So it's a very good illustration of what just the story you told of how mathematicians could work with Gen AI so far. So first you ask to break down and describe the task, and then you work step by step with it. You clearly filter it in, asking the right question, using the right tool, giving the right data, basically the papers, required knowledge. And finally, you filter out the quality to double check and iterate to be sure that when
Yeah.
there is some issues.
But I would not be so positive, because in the end, I spend, I think, more time to read what was written than if I had to produce myself. And the point is that I don't want my job to become to become a human being reading what a machine produced. Like if I were a journalist, I ask to write an article on something, and then my job just is now to read what is written and to change this and this. But it's not really what makes us happy with mathematics. What I like is that I do work on my own, on my problems, and to try to find myself the solution and so on. Then there are things that are a bit painful, like I think for all mathematicians, like writing papers, because once you have cracked the problem, sometimes you consider that it's done, and you have all this part where must write papers and so on. So it can have an interest, and also it can be very useful if you have no idea on how to start, and to give you ideas and so on. But the future where you would be just someone checking things, and given that we are human beings, and so we also do a lot of errors, because you can be tired this day, you can have some familiar problems, or I don't know, but your machine does not face this kind of problem. So yeah, so for sure it questions a lot, but we cannot say that the future will be like this and like that. So I mean, it will also depend a lot of people, I would say, how they will deal with them. Yeah.
So this leads perfectly to this part of the discussion in how this will affect the way we work, and in particular in math here. So what you're saying is also echoing other discussions I had, basically of sometimes, for example, with legal work, with coding, you can get some answers, and debugging, correcting, going back after is sometimes way more costly than if you started on your own and spend more time initially. But for example, legal work is the perfect example. So I had this lawyer, attorney-in-law, who joined on one of the first podcast episodes, and she told me that the nature of her work really changed. Like, people don't come to them to write contracts. They do it with LLMs, but they come when they have issues. And it's way more costly, because when the professional look at the contract, they really are like, of course you have an issue now. It's way more costly to solve these problems with legal work for months than starting right. And with coding, sometimes it's the same. You go faster because maybe you don't hire an additional engineer in your team and you vibe code your platform. But at some point, it might clearly backfire with some security breach, with everything collapsing, with the lack of control on all the details. And here, also connected to this, what I appreciate in your answer and what you highlighted is also the nature of what we like doing as humans, and what we want to automate, what we don't want to automate. So it's not just for productivity. You really said, like, you also enjoy doing math for the sake of math, and that's why I guess you're a mathematician,
exactly.
and not just reading and correcting, like, from your infinitely available and patient assistant who do some mistakes. But that's typically where I wanted to go with this third part, is about how math will eventually evolve, and linking this also to junior, how they should use these tools, and yeah, what do you think about this?
But first, maybe we can explain how it could work. So I mean, to produce math from the very beginning to the end, because math, like you say, seems like the perfect field for automation. It's because you can check, it's verifiable, and so on. But as I told you, in reality, it's much more complex because doing math means going through several stages. So first, you must have the idea. So what about creativity of this object of these LLMs? So I mean, but you must first have the idea. Then you must find the sketch of the proof. So here maybe they can help. Then you must build each step, so the proof of each step, and in the end you must check everything. You must verify. And these last steps takes time, care, expertise, and this is maybe here that we have the biggest problem with the automation. So because LLM can hallucinate, we have said, and if you, for instance, if you say, okay, I have an LLM who can produce math and which is correct 99% of the time, okay, so which seems to be big. But if you decompose your proof into many steps, imagine you have 100 steps in your proof. So it's like you say 99% of 99% of 99% 100 times, and this the result is 37%. So meaning that if you multiply all this 99% 100 times, it becomes 37%. And so 37 is more failure than success. Right? And the point is that you have no idea where the error will be. So you have to read everything. And so in the end, do you really gain time? I'm not sure, because, and also it can be very boring because you can have everything correct. And at some point, shit, there is something wrong. and so, but this is the same way than when we do research. So sometimes we have the idea that this is clearly true. Or it's straightforward to prove, and so on. And then when you try to prove it, it becomes less and less straightforward and less true. And sometimes you discover that there is a mistake and you have to do it again, and so on. So in this respect, it's like a bit what we do as human beings. Okay, so, and also, as I said, the technology for checking mathematical proofs exists. So this is Lean, as I mentioned, MathLib. So, but there is not only Lean, but they are called proof assistants. So the idea is that you write your proof like a computer program, like code, and the system checks every line. So if it's correct, it says okay. If not, it stops. Right? So you could say, okay, maybe we put together an LLM for producing proof and Lean to check whether it's correct or not. But we have this lack of data, as I mentioned. So the main issue is that the development of MathLib, which is a library associated to Lean, is far behind the current mathematical production. So we are still maybe a few % of mathematics has been encoded. And at the same time, the number of papers published or posted on arXiv every day is big, and the production is about to explode. So we have a problem of scaling, as you say, yeah. And also, but it's a problem in general, because I think mathematical research nowadays has reached a point where verification does not exist anymore. I'm not sure when I take a paper that it's true or not, because there are too many papers, and the way it's done in order to check if a paper is correct, normally it should be done by the authors because they are responsible for their work. Then you have reviewers. Mathematics in general is 2 reviewers, but they check more for plausibility. Exactly. So you look at it, it seems correct or not, but they are not doing this line by line because it's impossible nowadays. There are too many papers. And if you would like to do it seriously, you would become it would be your daily job every day. So you can do nothing more than this, just checking papers by others and so on. And so, of course, it's not done. And the readers also who are using these papers, they often cite papers based just on the abstract or the author's reputation. And so I think we have serious errors can remain hidden even for years. And there is a famous example for this, the ABC conjecture. I don't know if you know about it. So this is a conjecture, and we have a proof which has been published for 5 years now. And this proof, so it's a very hard mathematical problem, but the community still does not consider it verified. So it is published as a theorem, but still the specialists don't say that this is correct. So you see that we have some gap between, even if the paper is published, so you can think of, okay, I'm going to use it because mathematics is like stacks. You have axioms and then you put theorems and so on. But we have a very serious problem that we are not sure at all that all mathematical papers, even published, are correct.
That's really interesting to me. So first I was surprised, and then I was thinking about research in my field, economics and econometrics. And basically, well, first, when you have theory, usually I guess it's easier. But if I think about empirical work, people will verify the source of the data, the equations, eventually the code, which is honestly rarely, not always the case, rarely done. In particular, in economics, in many papers, journals, they don't share their code and data, so it's very hard to replicate the results. So in the end, actually, I was initially surprised by what you said in math, but I think it's just essentially what often happens because you don't have enough material to replicate anyway. So you have some level of trust looking at, for example, econometrics, at the equation, the model that was run, and the output that is showed in the tables, while not running the code. And we had scandals recently of different situation of people who just seemingly manipulated the data.
Yeah.
And this is very hard to control and verify, and few people will spend time doing this. So it's very interesting that you share this for math, but now I start understanding a bit more indeed the complexity and the rationale for this situation.
Mm-hmm.
And so what's basically what are your so do you still teach in academia?
Yeah, of course.
Yeah. Okay. I thought so. I just wanted to be sure. And what are typically, do you address this topic with your students? What's your position and recommendation?
As a point, I am the director of the bachelor, and when we do our exams, they are in a room with no material and so on. So of course, there are certainly a bit some cheaters. But normally, it's done in a way that they can't use LLMs to solve their exercise. But then we have the memoir. And for this, for the moment, what we grade is a memoir in itself. So meaning that we give the student the problem, some references, and then they must create a document showing us that they understood the problem. They were able maybe to produce a bit new results or incremental results, but maybe you are in a paper when the proof is just written, it's clear, and then they fill the gap and so on. So 5 years ago, it was enough, and you could have a memoir like this, which was excellent, and then you get the student an excellent grade, and you are sure that so the grade was corresponding to the level of the student. No, I mean, if we keep the same exercise, if I were a student, maybe my first idea would be to give my subject to an LLM, and then it starts difficult to compete with students not using it, or even with my colleagues who have no idea that we can produce a memoir in 10 minutes instead of a semester, and which would be much, much, much better than what they produce without this technology. So now we have to think ourselves how we grade again. So now we should not grade the content but the journey to go to this content. And I try to have a debate with my colleagues where now I would like to propose two options to the students. Either they keep the old-fashioned way, but if they use an LLM without saying it becomes to be a fraud. Or they say, okay, I will do my memoir with an LLM, but no, what we grade is not the output, but more the journey too. So how they chat with ChatGPT, what they did, what they learn, how they question the thing, and so on. And if they document exactly like I did with my research paper we mentioned, I mean, it's okay because you understand what the student did, that he did it in an appropriate way and without hiding the fact that he was using an LLM and so on. But for the moment, we are still in discussion with my colleagues because there is a gap between students. So they use massively LLMs like ChatGPT, but without expertise. So they are not able to, and my colleagues, they have the expertise, but they don't want to use LLM because they think that it's like, but it's a bad object, it's a bad thing, and so on. And so, yes, we have to navigate between these two things, and it's not easy. So, I mean, it's very challenging.
Do you see did you witness a change in the level of the students? Maybe their capacity to learn or the result to tests?
But for instance, for the memoir, I experienced that they are much, much better now than they were 2 years ago. There is no grammatical errors. The written part is perfect and so on. But it's just because they just plug it into an LLM. No, for the level of the students, for the moment, I would say that there is no, I don't see, I'm not saying any difference. Because it's quite new and still students like to study the old way, I would say. But I have two daughters, and my youngest one, so she is 15 years old, and she uses a lot ChatGPT to do a lot of things. And I worry more for her because you don't know what she really learned. Of course, for her, she's able to do the homeworks perfectly and so on. But in the end, she does not have the maturity to think that to understand that she's learning. And so, what matters is not what she produces, but what she learns. And try to discuss with her and to explain her and so on. But I think we will see the effects in like say in 5 years or something, the next generation. Yeah.
Yeah, because we can always argue, and you have some research papers on the impact of Gen AI on learning. You can use these tools like Notebook LM to eventually help you to boost your learning capacity by just helping you go over a document in a varied way, connects different dots, even ask you questions. So you have different ways that has been explored to help you learning. The thing is, we humans are often lazy and we'll take the shortcuts, and there are no shortcuts even for learning, right? As we said, you need to struggle to acquire the muscles, basically, and this is where indeed it worries me as well. It's how this will evolve and how we can build the incentives. So actually, I will teach starting in February a new class, research and generative AI. And every class will take one part of research in economics and show the old-fashioned way, let's say, how we can use Gen AI. Then they will practice and will debate and judge critically the pros and cons. And we'll see the limitation, eventually where it can be useful. And the final product will be, so the output of the class will be a proposal for their thesis, for their research. So and I will evaluate indeed, like you suggested, the output, but also the whole journey and how they use AI and how can they think critically about their use of generative AI. And one of the advice that follow us during the whole class is that you should always reflect and make this choice, because like really reflecting if you want to use Gen AI or not, because most of the time you might gain some productivity eventually. It's not always the case, as we mentioned, if you have to correct the issues, but also you have to evaluate what you're losing. and typically learning capacity.
Yeah.
And then basically eventually it might be justified. Like I do my own website. I don't want to learn again if I use to build a website on my own. I don't want to learn again like a CSS, JavaScript, React and new stuff and spend time to do my personal website. So I will vibe code it because it's just a simple static website. And here I'm fine. I accept the fact that I will not learn this capacity because I want to focus on maybe doing where I'm an expert, right? So yeah, we'll see where this leads and how we can basically.
Yeah, my point is that for us it's okay because we knew the whole world and we know just it allows us to be quicker. Like I vibe code and I augment my teaching by vibe coding. You know, I have a QR code where the students can scan it and on their smartphones, then they can select between 1, 2, 3, 4. And when I teach probability classes, we have many exercises where the result of the exercise goes against intuition. So I like to ask intuition before, so they vote and so on, and then we solve the exercise and we see the difference. And it's very nice this way because they use smartphones and so on. They are very happy. The point is that, yeah, but for my daughter again, so I mean, she does not know yet. So she will use a lot of tools like this, but without any idea of what she is doing. And in the end, yes, this is our future employees, future people who will pay or retirement. And so, yeah, but it's difficult. So I mean, for us, again, I think it's very nice. I'm very happy to be born exactly to have my age now because I can really play with AI. I find it very nice and so on. But I'm not sure I would have been happy to discover this when I was 10 years old, because then you get all the learning process. But we'll see where it goes.
Yeah. So before I ask, so for me, I 100% again agree with you. I was way too lazy when I was young, between 10, 15, before being very passionate, and really like, yeah, obsessed about what I've been doing and learning, then discovering causal inference and statistics, but it came later. I think as a student, I was way too lazy and it would have killed eventually all my learning capacity because I already loved computers. So certainly I would have spent a lot of time playing with these things, automating everything and eventually learning how to use Gen AI, but nothing else. So maybe to wrap up, and this final question that I like to ask, we already went in this direction, but maybe with final thought of, are you more hopeful or fearful about where this is going?
In general, I am hopeful. So I see that this is really, we are really augmented with this technology, and I use it, even not speaking about math, but I use it a lot myself. But then we can worry about what we will lose from this. And so for the moment, we have no real idea about this. But okay, human beings are always, so this is not the first time that we have we have a new technology. So maybe it's the first time that we have a technology which has been adopted so quickly by all the planet. But it's not the first time that we had technologies that change the world. Yeah, so I'm more hopeful than than the contrary.